Hello and good afternoon friends, welcome to CEC-UGC live lecture. Dear friends, as you know, this session of ours is all dedicated to science subjects. As we have been talking a lot on the environmental sciences, our previous lecture was also on the environmental science. Today also we are going to talk on a very important topic. You might have heard about particulate matters. These particulate matters contribute in so-called air pollution. How it basically works, what are the ingredients or what are those chemicals, compounds which forms particulate matters which further cause air pollution. We will be going to discuss all this in today's lecture, and for this we have again with us in our studios Dr. Arun Srivastav. He is Associate Professor in School of Environmental Sciences, Jawaharlal Nehru University. So first of all, I would like to welcome our guest Dr. Arun Srivastav.
Thank you.
So welcome to the EDUSET lecture. As we have been discussing a lot on the environment and environment related issues, but most of us are still unaware what are those matters which actually contribute to the air pollution. We hope that from today's lecture we are going to learn all those concepts and things. So over to you, sir.
Thank you. Today I will speak on air pollution. One of the very important parameter or the contributing factor of air pollution is particulate matter. So first I will give some information about the air pollution. Later on we will have elaborate discussion on particulate matters. So as far as air pollution is concerned, it is not the present day's problem. People had been concerned from since ages. And as far as historical purview is concerned, in Middle Ages, smoke from burning coal was considered serious. That is why King Edward I banned its use in lime kilns in London way back in 1307. In 1948, 20 deaths and over 6,000 illnesses out of 14,000 population were reported due to air pollution in just 4 days periods in Donora, Pennsylvania. And we all know about Great Smog disaster, which caused a death of around 400 people in just 3 days in 1952 at London. And we all know about 1984's great Union Carbide disasters, which killed over 1,000 people in just few days because of a very lethal gas that became the part of air, and that was methyl isocyanide. So starting from air pollution, what is air pollution actually? We can define it as any visible or invisible, biological or non-biological particle or gases found in the air that is not part of the original normal composition is called as air pollution. So first we should know what is the original composition. Atmosphere has a fixed composition which contribute around over 78% of nitrogen, 20%, around 21% of oxygen, 0.934% of argon, 0.04% of carbon dioxide, and we have neon, helium, methane, hydrogen, nitrous oxide, kryptons, ozone and water vapor. It constitutes around 1%. Here in the right hand side we have a pie chart which depicts the contribution of different gases in the atmosphere. We will say N2 is overpowering all other gases. O2 has also a significant contribution, but remaining is just 1%. We have further magnified it and we will see that Cu has a significant contribution, and remaining there are many other gases. So what happens when this composition is changed or the constancy of this composition is changed? We can say that air is not normal or air is not natural. It can be termed as a polluted air. So what could be the reason of air pollution? There are many reasons. So if we divide it on the basis of its nature, it can be natural or anthropogenic. What are the natural reasons for air pollution? They are volcanoes, forest fire. And as far as anthropogenic reason is concerned, there are several. It is industrial, vehicular as well as domestic. Air pollution can again be subdivided on its character basis. They could be biological or non-biological. In biological pollutants, it could be viruses, bacteria, fungi, pollen, dust mites or animal dander. In non-biological, it might be having all the phases, that is solid, liquid, gases as well as multi-phased. What is solid? It is basically particulate matter. Liquid could be acid rain, and gases, there are several over hundreds of gases in the air as a pollutant, as well as the multi-phased. It could be sulfate or nitrate aerosols. Now, coming to particulate matter, the first one, we will have discussion on this. What is particulate matter? Particulate matter is also called as atmospheric particulate matter, or simple SPM, or suspended particulate matters, or sometimes it is just called as particulates. And it can be defined as they are the particles of solid or liquid matter suspended in the Earth's atmosphere, sometimes also known as aerosols, a term which refers to the particulate and air mixture. Aerosol is basically the combination of two words, aero plus sols, means the particles which are present in the air medium. Its size can vary, in general its size can vary from 0.001 micron to up to 20 micron, and it is possible only in the calm environment. I mean, the conditions are not windy or turbulent, but when the environment is not calm or the environment is turbulent, the size, the upper range can go up to 100 micron, or sometimes even more than 100 micron, thus making the total size range from 0.001 to 100 micron. Now, what we are actually concerned as far as the particulate matters are concerned, its size, its composition, and its concentration. These are the three factors which people are really concerned, because it plays a very significant role in various things, whether it is health, atmospheric problems, or pollution. Now, size distribution. If the particles are more than 50 micron in size, it can be easily seen by bare eyes. If the particles are varying between 0.1 micron to 10 micron, it cannot be seen by bare eyes. For that, we have to apply some kind of microscope. Compound microscope will be enough. But the particles, if the particles are less than 0.1 micron, they can't be seen either by compound microscope or bare eyes. For them, we'll have to apply some very high, very sophisticated instruments like electron microscope, etc. What are the genesis of those different sizes particles? How they can be formed? If the particles are less than 0.05 micron, they are product of either high temperature combustion or some kind of chemical processes, or by condensation of vapor. If the particles are between 0.05 to 2 micron, then they are usually formed by coagulation or coagulation of smaller particles, or from the particles through vapor condensation. If the particles are more than 2 micron, they are generally formed by mechanical processes such as grinding, wind action, soil erosion, and also because of agglomeration of smaller particles. Now, on the basis of their size, particles have been subdivided into different 4 categories. They are PM 0.1, they are also known as ultrafine particles. PM 2.5, they are known as fine particles. PM 10, they are known as respirable particles, and those particles which are more than 10 micron, they are known as coarse particles. Generally, particles are divided into different 4 fractions. I again say they are coarse, respirable, fine, and ultrafine particles. Why this is the type of distribution that we have adopted? If you see this picture at the left hand side, upper left hand side, you will see the particles which are more than 10 micron in size, they will get deposited in the upper part of our respiratory system. There is the black portion in the human system here. It is the place where the particles of larger than 10 micron have their place. And apart from all this, they have some other physiological effects also. Like in this portion, the particles get a good amount of moisture, and by absorbing those moisture, they become heavier, and afterwards they start striking on the walls of throat, nose, and etc. And that basically causes the irritation of nose or mucous membrane, and people start sneezing. And what happens when people start sneezing? The chances of these particles to get out becomes more. So we can say if the particles are deposited there, they might also be eliminated by sneezing, coughing, nose blowing, spitting, or sometimes by digestive system. And those particles which are less than or up to 10 micron, or we can say the particles from PM10 or lesser, they have the chance of getting deposited in the middle part of respiratory system, that is known as tracheobronchial region. What happens here? The particles may be either removed by sneezing, coughing, or by digestive system, or else they may remain there for a significant period of time, and that is a matter to be concerned. And the particles which are of the size 2.5 or less than micron, they have their place deeper inside our respiratory system. Here in this picture, the black portion is basically, it represents the alveolar duct or alveolar air sacs or alveolar walls. Here the particles less than 2.5 micron, they get deposited, and from here it becomes very difficult to flush them out, and because of this they might have some chronic effect. And the particles which are ultra fine, or the particles which are very, very small in the sizes, what happens to them? After reaching to the alveolar sac here, the chances of those particles to be absorbed by tissues becomes very significant, or in other words, we also say that they might go interstitialization. It means that the particles, if they are deposited there, the chances of them to come out is very, very difficult, or it is impossible. So from there, if they reside there, sometimes afterwards they have the chance to be absorbed into the bloodstream, and from there they can never be removed, and from there they start having some kind of mutagenic or carcinogenic effects depending upon the nature or the chemistry of the particle. Now the particles here, the different type of particles which has some names, they have been divided into various categories depending upon their sizes. Like those particles which are over 10 micron, they can be visible by the bare eyes. The particles which are under this category are pollens or spore, or sometimes sinking smoke. And here, I can say that the particles of more than 10 microns are generally of biological origin or of biological nature, and the particles which are between 0.1 micron to up to 10 micron, they are biological as well as non-biological. They are house dust mite allergens, bacteria, all smoke, etc. And these particles can be, I have already told that these particles can be seen by compound microscope, and the particles which are lesser or fine, ultra fine, between 0.1 to 0.001 micron, they are atmospheric dust, environmental tobacco smoke, soot or viruses. They can't be seen by bare eyes or microscope, they can be seen by electron microscope. And even further lesser particles which are gas, basically VOCs or ozone, tropospheric ozone, they can neither be seen by electron microscope nor visible or bare eyes. So this is the categorization of particles depending on their sizes as well as on the chemistry. So what could be the composition of those particulate matters? What type of these particulate matters can be as far as this chemistry and their composition is concerned? They have further been subdivided. They are mineral dust. First is mineral dust. Mineral dusts are made up of mineral oxides like silicon oxide, aluminum oxide, iron oxide, oxides of iron, or calcium oxide, and sometimes other oxides also, carbonates like carbonates of calcium and magnesium, and other materials which are blown from Earth's crust. And basically they are natural origin particles, and they have a character of absorbing the light. And afterwards, the next one is sea salt. It basically consists of sodium chloride as well as chlorides and sulfates of magnesium, calcium and potassium. In addition, it may also contain organic compounds which might influence their chemistry. It is considered to be the second largest contributor in the overall global aerosol budget. The third one is organic particulate matters. It is also known as OM. It is basically the organic material in the atmosphere, may either be biogenic or anthropogenic. It can be primary as well as secondary. And in fact, the later part deriving from is made up of oxidation of VOCs, It can also influence the atmospheric radiation field by both scattering as well as absorption. The next one is soot. What is soot? Soots are also known as elemental carbon or black carbon. These are basically pure carbon in several linked forms. It is formed through the incomplete combustion of fossil fuels, biofuels and biomasses. These are strong light absorbing material and is thought to have large positive radiative forcing. And organic matter and elemental carbon together constitute the carbonaceous fraction of aerosols, and we usually say them as carbonaceous aerosols, and they are basically a very big threat to our health. And apart from them, the next one is, apart from these, we have secondary aerosols also. They are known as secondary particles. They are originated from the oxidation of primary gases such as sulfur, oxides of sulfur and nitrogen into sulfuric acid. I mean, now it gets converted into the liquid form, and nitric acid, which is a gaseous form. And the precursor for these aerosols, that is the gases from which they are originated, may have an anthropogenic origin, I mean from fossil fuel or coal combustion, and a natural biogenic origin. In the presence of ammonia, secondary aerosols often take the form of ammonium salts. And these ammonium salts and ammonium nitrate are making them ammonium sulfate and ammonium nitrate. And they are very strong scatterer of light. And these were the non-bioaerosols. Now we will discuss something about bioaerosols. Defining bioaerosols. Bioaerosol is an aerosol comprising particles of biogenic origin, whether it is living or dead. It may affect living things through infecting or by putting allergy, toxicity, or it has some pharmacological causes as well. And their size might vary in aerodynamic diameter from 0.5 to 100 micron. Now, how the concentration of aerosols can be estimated? The concentration can be estimated by this formula, that is concentration can be estimated using the formula, that is mass of particles upon volume of atmospheric air. The units of the concentration of particulate matters can be milligram per meter cube or per feet cube or per liter, or it could be microgram per meter cube, per feet cube or per liter, as well as it could be nanogram per meter cube, per feet cube or per liter. But mostly the middle one, that is microgram per meter cube, per feet cube or per liter is used, and among these three, the top one, that is microgram per meter cube, is widespread, and that is generally used especially in India. How the particulate concentration, in fact these were the formula for estimation of concentration of particulate matters, how these concentrations can be obtained. There are different two methods for obtaining the concentration of particulate matters. It is continuous method, and the next one is semi-continuous method, that is also known as filter based method. And in fact both these methods can be applied for total particulate matter estimation and size resolved particulate estimation. I mean, using these two methods we can have the idea of total concentration of particulate matters as well as the concentration of different sized particulate matters. Now, what are the continuous method? There are main three different continuous method. The number one is optical method, the second one is beta attenuation method, and the third one is known as QCMB or quartz crystal microbalance method. Starting from the first one, that is optical method. What happens when it is, in fact it is based on the principle that when shining, generally it is laser, shining electromagnetic radiations strike on particles, it is scattered away from its original direction. This scattering depends upon the size and number of the particles. With a suitable photomultiplier, number against the size of particles can be determined. The schematic of the instrument is given here. In this picture, we will see a pump, a mirror, a filter, a scatterer, that is also known as detector, and afterwards there is a monitor. So what happens? The particles are pumped through the filter, and a laser is also applied on those particles, and particles start scattering the laser light, and the photomultiplier is such as the refracted or the scattered light between 5 to 175 degree is monitored or is taken. So, those particles which scatter the light, they are monitored, and the amount of light which are being scattered, it depends upon the size of the particles. Thus, the sizes are also determined. So, in this way we estimate two things, one is size, another its number. And what are the different instruments that are made up using these techniques are nephelometers and athelometers. Nephelometer is basically applied for monitoring of dust, while athelometers are used for the monitoring of black carbon. The next one is beta attenuation. What is the principle of beta attenuation? Here in this, the main principle is based on Lambert-Beer's law, and it says that the amount by which the flow of beta radiation is attenuated by a solid matter is exponentially dependent on its mass. In fact, the air is drawn from outside of the detector through an infinite filter ribbon, so that the particles are collected on it. And in fact, there are two sources of beta attenuation. One is which is placed before the sampling, and another one is which is placed after the sampling. Here we can see that number 2 is basically a ribbon based on filter, and it rotates, and there are two radiation sources. In fact, the radiation sources which we used are krypton gas, or sometimes it is carbon 14 too. So, what happens, the number 3 and number 4 are the sources of radioactive material, and they emit beta particles, and it is being sensed, it is being detected by the detectors. They are D1 and D2. So, in one place at D1, the filter ribbon is without any particle. So, we are getting some concentration of beta 1. At 3, the radiation which is being detected by 2 is after the particles are deposited on the filter papers. So, in this way beta is reduced. I mean, the beta which is being detected at D1 is more than the beta which is being detected at D2. In this way, the reduced amount of beta particles gives us the information about the particles that has been deposited, and the particles deposition is the particle is being pumped at number 1, and it is going out through 5 and 6. So, in this way the amount of particles deposited on the filter papers or on the filter ribbon are estimated. The next one is quartz crystal microbalance method. It is also known as tapered element oscillating microbalance. So, what happens in this? In fact, there is a tapered element which keeps on oscillating on a natural frequency. It has got a natural frequency when it is supplied with some specific amount of voltage. And afterwards, what happens? Since it is vibrating on a frequency and particles start depositing on that tapered element, so the frequency which was natural or which was specific sometimes back changes, and this change actually gives or comes out in the form of electrical signals. This change electrical signals might give us the information about the amount of the particles that has been deposited on the filter or on the tapered element. Apart from these, there are semi-continuous methods also which are widely used, especially in India we use such kind of methods. They are basically high volume samplers. What is done in high volume samplers? We mount a filter paper, and through that filter paper airs are supposed to pass, which contains the particulate matter. So, what happens after some times, the filters get deposited by particulate matters, and after a fixed period of time, let it be 24 hours, what do? We take out the filter paper. So, now the mass of the filter papers is changed. W1 is the mass or the weight of the filter paper when the sampling was started or without any particulate matter, and W2 is the weight of filter paper when the sampling is being done, and V is the volume of air that is actually passed through that filter paper. So in this way we can estimate the amount of particulate matters. I mean, W2 minus W1 upon V is the formula, and V basically is the total amount of air that has been passed, that can be obtained using multiplying average flow rate by total sampling time in minutes. And here we usually give the units in the form of microgram per meter cube. And apart from that, we also can have the particulate matters in the form of size segregated form. And how it is done? Here we apply a cascade impaction technique, and what is done, we have a stake of samples, we stake of filter papers, and air, if you see the picture at the right hand side, you will find the air is entering from the top of the sampler, and after striking the first filter paper, it is getting a cascade effect, and by that cascade effect it is entering into the second filter, and so on, and finally it is reaching to the nth stage. It depends upon how many stages or how many different sizes we want to take. Suppose if it is 6 size, so we will have different 6 filter papers, and the largest particle or the biggest particles will deposit on the top filter paper, which is the top, and the particles which are lesser, immediate, which are having the size immediately lower than the preceding one, will deposit on the second filter, and so on. It will keep on, the process will keep on going till the particles, smallest particles get deposited on the final filter paper, that is the 6th number filter paper. So in this way we can have the size resolved particulate matters. Apart from this, we have another technique that is also known as cyclone sampler. What happens in this, we cannot get the particles in different sizes, but we can get the particles in a specific size. Suppose we will have to have the particle of 10 micron. It could be either 10 micron, 2.5 micron or 1 micron. So what is done? A head is mounted, and that head is the geometry and the type of shelter is such that the particles which are larger than 10 micron is scattered or it is blown away, while the particles which are 10 micron or lesser will get deposited on the filter paper. So the heads can be selective. If we apply 2.5 head, we will get the particle of 2.5 range. If we apply the PM1 head, we will get the particle of particles of size 1 micron. Now the particles after the sampling, this was in fact these were the sampling methods. Now the analysis part, how the particles can be analyzed. Particles can be analyzed in 3 different ways. One is chemical, another is physical, and the third one is biological. So how the chemical analysis are done? Chemical analysis can be done using different sophisticated instruments, either atomic absorption spectrometer, ICP, that is inductively coupled plasma mass spectrometer, X-ray fluorescence, energy dispersive X-ray analysis, that is also known as ZX, or PIXI, that is particle induced X-ray emission. And these in fact these instruments are applied for the estimation of different heavy metals of periodic table. If we have to analyze the particles for ions or organic compounds, then we can apply any of these instruments, that is UV or visible or IR spectrophotometer, HPLC, that is high performance liquid chromatography, or ion chromatography or gas chromatography. These 3, HPLC, IC and GC, are applied for the analysis of organic compounds, while the UV spectrophotometer, this is applied for the estimation of ions, inorganic ions. Now the physical analysis, how the physical analysis are done. Physical analysis can be done using XRD, that is if we want to estimate the crystals, what type of crystals are present into the suspended particulate matters, or using scanning electron microscope. With the help of a scanning electron microscope, we can have the information of morphology or the shape of the particles. The next one is ESEM, that is also known as involuntary scanning electron microscope. With the help of ESEM, we can understand the phase change of the particles at a specific pressure or temperature. If the particles are deliquescing at some specific pressure or temperature, this can be done, or this can be determined with the help of ESEM. Next is biological analysis. Again, the biological analysis can be done either using the continuous method or non-continuous method. So, we say them automatic or continuous method, or manual and non-continuous method. So, what is the sampler, that is the one at the left hand side, is basically automatic sampler. It might give us the total information about the bioaerosols, but it can't give us information about the nature of the particle, what is basically the composition of the particles. And the samplers which are at the left hand side, right hand side, or the manual samplers, the one is a sampler which can take the particles in different sizes, and one which is smaller is it can take the particles in all the particles. It is not basically the size resolved sampling. In fact, what is done in this sampler, in these samplers, is we put a petri dish which contains a media. This can be seen here. The petri plates which are containing the media are placed inside those samplers, and the sampling is done. It is the same process that was discussed in case of filter paper. The sampling can be done for some specific period of time. Afterwards, the petri plates are taken and they are incubated for some times. There are specific protocols for its incubation. What is the period? What could be the period for its incubation? After incubation, the particles can show visible growth of colonies if it is bacteria, or if it is fungi, or any other biological agent. And after its growth, the colonies, the visible colonies, can be counted with the help of colony counter. And if we want to do further analysis like its microscopic examination, etc., that can be done by taking some portion or some other methods. And now here in this we can find what are the different mediums that can be selected for different type of bioaerosols. If we want to sample, or if we want to estimate the fungi, we will have to apply the potato dextrose agar media. If we have to do for gram positive bacteria, then we can apply the blood agar media. If it is for gram negative bacteria, then we will have to apply eosin methylene, blue agar. Or afterwards, the colony forming units are given in the form of either total colony or in the form of colony forming units per meter cube. And if we want to further analyze for its species, etc., then we can apply some advanced instruments like PCR, that is polymerase chain reaction, etc. Now, what are the methods how these particulate matters can be controlled? There are specific methods for controlling the particulate matter. The number one is air filters. Basically, air filter is a kind of device which is composed of fibrous materials which removes particles such as dust, pollen, mold, and bacteria from the air. In fact, in this, a chemical air filter consists of an absorbent or catalyst for the removal of airborne molecular contaminants such as VOCs or ozone. The next one is air classifier. What air classifier does actually, it in fact works by injecting the material stream into a chamber which contains a column of rising air. There, an upward force is applied on the particles by those rising air, which counteracts the gravity in fact, and lifts the particle into the air. Due to this dependence of air drag on the size and shape, the particles are shorted vertically and can be separated in this manner at different levels. The next one is cyclone separator. What does cyclone separator do actually? In fact, this is a method of removing particulate matters from an air, gas, or liquid stream without the use of filter papers through vortex separation. And in fact, in this, rotational effects and gravity are used to separate mixture of solid and fluids. The method can also be used to separate fine droplets of liquid from a gaseous stream. The next and the important, in fact, this is widely used controlling mechanism, that is ESP or electrostatic precipitator. And this method is now it has become mandatory in the power plants where a large amount of particulate matters are released. How ESP works actually? In fact, ESP contains a row of thin vertical wires and a stack of large flat metal vertical plates. And in fact, the air stream which flows horizontally through the spaces between the wires, and then it passes through the stack of plates. And afterwards, what happens? A negative voltage of several thousand volts is applied between the wire and the plates, and then this, in fact, this applied voltage is high enough that an electric corona discharge starts ionizing the gas around the electrodes. And in fact, these ionized particles following the negative electric field created by the power supply move to the plates and get deposited on the plates. And from time to time, these the particles are removed from plates. The next one is wet scrubber method. What is done in wet scrubber method? Basically, it is a device that removes pollutants from a gas system, mainly flue gas. In wet scrubber, what happens? The polluted gas stream is brought into contact with the scrubbing liquid by spraying it with the liquid. In fact, a mist is created over there by forcing it through a pool of liquid or by some other contact method, so as the particles or the pollutants are removed. I mean, now I have finished till particulate matters, and next we can continue for gases pollutant, because we don't have much time.
Definitely, sir. We can continue more on the particulate matter.
Particulate matter is done so far. I think I have just a moment. No, it is done. Okay.
Definitely, sir. We are going to continue with the other part on the particulate matters.
No, gases pollutant.
We are going to talk on the gases pollutant in our next lecture. So, sir, if we talk about the particulate matters, if we talk in the common terms, in a general terms, so we can say the nitrogen is the most abundantly found particulate matter in the air.
No. Actually, what I said in the beginning, that our atmosphere has a fixed composition of natural gases. These gases are there since Earth, or since this entire our atmospheric system is made. So what is there, that the composition or the amount of nitrogen is maximum, that is around 78%. The remaining one is oxygen, that is 21%, and the 1% which is left, it is composed of many other gases. There are several gases including CO2, argon, water vapor, etc., etc. But what happens when this natural balance is disturbed? I mean, you are expecting 78% of nitrogen, 21% of oxygen, etc., etc. But if this is not the situation, you are getting some other gases which are not supposed to be here, then we say that air is polluted or the pollution is there. And as far as the particulate matter is concerned, it might have different chemistry. It can have different type of chemistry as well as a size and shape. Sometimes they could be liquid, sometimes they are solid. Generally they are solid. Sometimes they could be liquid, and sometimes they could be multi-phased. I mean, they could be liquid as well as solid. The solid particles are incorporated with liquid. They are also known as multi-phased suspended particles.
If we talk about the composition of these particulate matters, as we talked in our previous lecture also, that if we go in different regions, the composition changes or it may be different.
Yes,
so, does this particulate matters have different composition in different areas?
Yeah, definitely. In fact, this can have a very highly variable chemistry. If we are in an industrial area, the chemistry of these particles are different. It might contain, depending upon the type of industry there are. If the industries are such that they are emitting toxic elements like heavy metals, etc., which are toxic to the human beings, the particles are bound to have those metals. If we are, suppose if we are in some desert area like some portion of Rajasthan, etc., there the chances of getting some natural chemistry is more. I mean, the particles which are there might have some natural elements which are found in the Earth's crust, like it could have iron, aluminum, magnesium, etc. or silicon. So, it depends upon the place where we are, and the chemistry, in fact the chemistry depends upon the place where we are monitoring or determining its composition.
As you said, if we talk about the desert area, there the composition would be something else. Likewise, sir, if we talk about all those regions which are near the sea or vice versa, or in the middle of, if we talk about India, in the middle of the India, for example, this Deccan Plateau region where we are in the middle. So, there also the composition changes, and the Earth's atmosphere is in the some way or the another is causing the this air pollution or air composition.
In fact, if we take your first question, if we are near the coastal area, the nature of the particles will be salty. Chances of the particles to be having salts like calcium, magnesium, chlorides of calcium or magnesium, sometimes even sulfates of calcium or magnesium will be more. So, the particles will be of salt nature. If we are in the middle of, if it is a highly vegetated area, then chances are there that the chemistry of those particles could be of organic nature. I mean, it could be either biogenic or particles having some organic compounds, which are, the chances are that in fact they are natural, but it is natural means they are coming from some vegetation, whether it is alive or the dead vegetations.
Sir, as a whole, if I wish to ask you that is there any part in the country which we would call that it is pollution free? Can we say that this is a 100% pollution free area? Is it possible?
No, I don't think that. In fact, you are talking about country. If we talk about the total globe, even Antarctica is not 100% pollution free, because ozone hole, etc., what we are observing, it is there. And in fact, this ozone hole, concentration of ozone hole is Antarctica, because it is also not pollution free. I mean, somehow it has some relevance to the pollution, although it is not as polluted as the other parts of the India. Yes, we can have lesser or higher pollution if we are in some hilly area or in the areas which are far off from the industrial activities or vehicular activities. The chances are that they could have a less amount of pollution, but more or less all the areas are having pollution. One more thing I would like to say, that these pollutants in due course of time, suppose you are generating say pollution here or a pollution, in fact Delhi is a highly polluted area. It is not that the area which are surrounding Delhi will be cleaner. Over the time, this pollution which is being originated from Delhi will become the part of globe, or will become the part of, because air has no boundary, it has to move. Wherever air from Delhi goes, it will carry away the pollutant from Delhi. So, it will pollute those areas too.
Sir, if we talk about the garbage kind of material, for example, especially those which are not biodegradable, and if they are dumped for a very long time in a particular region, does they cause air pollution?
Definitely. In fact, it depends upon what is the degree of wearing and tearing of those biodegradable, non-biodegradable wastes. If wearing and tearing or the environment is turbulent, naturally over the time or in due course of time, those particles, those non-biodegradable items in due course of time will become the part of the atmosphere. After getting or after being removed from its mother item, it will come away and become, in due course of time, will become the part of atmosphere, and thus the aerosols.
Sir, same with the animals. For example, animals which have died in a large number in a particular area, and they haven't been cleaned from that particular area. Sometimes we have ourselves observed that after a particular time, the animal, they start fouling, that is a foul smell starts spreading in the air. So, does it has any contribution or any connection with the pollution?
Naturally, in fact, these are the source of bioaerosols. What happens if the animal dies? The bacteria will start acting upon it, because they become the food of those bacteria, as well as viruses. Fungi will grow. So, if the environment becomes turbulent or if the winds start blowing, so it is not possible that those bacteria, etc., will keep on attaching with those animals, with those dead animals. in due course of time, definitely they will become the part of air or in the atmosphere. So definitely the environment is now polluted with a new kind of pollution, but that is not the chemical pollution, but the biological pollution or the bioaerosols.
That is in some way or the another it is affecting the pollution. So we often use the term this acid rain. Acid rain is the consequence of air pollution, or
Yes.
it is the contributor of the air pollution?
No. Basically, it is the origin of acid rain is because of the air pollution. What happens? Air pollution or air might, in fact, in the next class I will discuss on this too. This as far as the pollutants, especially the gaseous pollutants are concerned, there is one component that is known as sulfur dioxide or oxide of sulfur. What happens? This sulfur dioxide, when it comes into the wet environment or when it comes into the contact of water vapor, so it gets or it forms a compound that is basically sulfuric acid. So it is acid. So what happens when rain occurs? This is now it is in the form of vapor. So what happens? This acid with the rain, it comes, and that is known as acid rain. I mean, there is natural rain, but it has some part of acid also. It has some acidic nature, and this is why this rain is called acid rain. And in fact, this acid rain is very dangerous to some historical, especially this acid rain, especially sulfuric acid, rain having sulfuric acid has the tendency to erode the marbles because it is highly reactive to calcium CaCO3, that is calcium carbonate, which are basically either limestone or marble. So once the acid rains falls upon the historical monuments, especially made up of marble, chances of corrosion and erosion is very much there.
So we often use the terms cigarette smoking is injurious to health, and it is always preferred that one should not smoke cigarette for oneself also and also for those nearby. Does this burning of the tobacco contributes or causes the pollution?
Yes, it is. In fact, yesterday in our indoor air class I showed there are thousands of pollutants that can be generated from a cigarette, from a single cigarette. Yes, some are very significant quantity, while some are in very small quantity, but there are. And one of those constituents is the particulate matters or respirable particulate matters. So the cigarette smoke, it definitely contributes or it adds to the particulate matters, but its significance is more inside the environment or in the indoor environments. It is less in outdoor environments. So one who is smoking, definitely he is responsible for the generation of suspended particles, or he is responsible for the enhancement of the existing particulate matters.
So this is the appeal to all the people who smoke cigarette, that please don't smoke cigarette yourself, because it could be harmful for others also. But sir, if we talk about all those people who basically cook in rural and urban areas both, for example in urban areas obviously we have the gases, we have cylinders through which we can cook our food, but in the rural areas we talk about wood. People still used to burn this coal and wood. So can we say that wood, coal and fuel
definitely
contributing to the pollution?
Yes, wood, coal, they are the you can say it generates huge amount of soot particles, what is I have already discussed, that is unburned carbon, and soots are very harmful to the health as well as to the atmosphere or the global radiation budget. It is also one of the reasons of the global warming. So coming back to the person who is cooking, what happens to him? He is highly prone to those soot particles, and in fact these soot particles have a very, it has a very unwanted health impact. So but in rural areas we have one advantage: their kitchen spaces are very open. It is not in a very confined environment, so whatever the smoke comes, it goes away. But if it is a room or the person who is cooking, he or she is in a very closed environment, so the degree of injury can be enhanced.
Fine, sir. But now the question is, it is the last question of this session. We have all many a time seen that people instead, because there are different types of garbages. Some required to be dumped or decayed inside this earth, and some are required to be burned. But sometimes we have seen that if a particular garbage is burned, it produces some particulates or some matters which started floating in the air. So what about these particulate matters which float in the air?
Naturally, I have already told this. It depends upon the type of garbage. If it contains some toxic element like chromium, nickel, cobalt, mercury, etc., etc., these are widespread used nowadays in many things. Suppose if some cellular phone is there, if some parts of the cellular phone are thrown in the garbage, or the batteries, etc., they contain toxic elements, and if we burn them, naturally these toxic elements will become the part of atmosphere, and these have a very toxicological effect upon the human being.
Definitely, sir. As you said that we have completed with this portion, and tomorrow we'll be discussing about the gases, pollutants. With this note, sir, we take your leave, and thank you so very much for delivering such a nice lecture, and hope tomorrow we would be talking more on this topic, that is on the particulate matters. Thank you, sir. Thank you so very much.
Yeah.